We are going to graph two functions today for the video. I have to repeat what I said because I wasn't recording when I did it the first time. It's all about Hollywood here, right, Andrew? Straight Hollywood. So, we're going to graph two functions, okay? We're going to graph sine, and we're going to graph cosine. Now, who remembers what sine and cosine look like? When I graph sine, first of all, I'm just going to sketch a graph here. What did I have listed right here on the x-axis? Kind of, sort of. We'll get to that. What did I have here? What kind of numbers did I have? 90 chickens? Degrees, right? These were all degree measures along the x-axis. And then what was the top of my function and the bottom of my function? 1 and -1, right? And then sine did one of these. And cosine did one of these. Except they're a little bit off from each other. But the general gist is they were waves, right? We're going to do the same thing, except we're going to do it with, what did we learn last week? Starts with an R, ends in radians. Radians, there we go. We're going to do it with radians. Do you think it's going to look any different? Is the shape of my curve, is the shape of the wave going to look any different? No, it's not going to look any different. The only thing that's going to change is what's changing. Instead of these being what? Instead of those being degree measures, those are going to be radian measures, right? Nothing changes. However, when an angle equals 90 degrees, what is that degree measure in radians? Those of you who did your homework and are ready to turn it into the basket should have this answer at your fingertips. That's what I thought. So let's do that measure. When an angle equals 90 degrees, let's do this together. When an angle equals, I don't like that, I like the calligraphy pen. When an angle equals 90 degrees, how do I turn that into radians? We showed you two methods. There was the Mr. Erickson method, which was to multiply this by pi over 180. Who remembers that? If only vaguely. Right? And then when I multiply these two things together, I get what? I get 90 pi over 180. Can I reduce that fraction?
Yes.
Yes, and what does that reduce to, Andrew? Pi over 2. That was the Mr. Erickson method. The Mr. Cook method was, now the advantage to Mr. Erickson method, that's an easy method, right? The Mr. Cook method is not as easy, but it does have an advantage, I think. I got that degree measure, and it's part of a whole circle, right? It's part of a circle that has 360 degrees in measure. And that's equal to my same angle in radians over what? What's a whole circle in radians? 2 pi, right? And then I solve for x. 90 divided by 360 is 1/4, right? And then times both sides by 2 pi. 1/4 times 2 pi gives me pi over 2, right? The advantage of this is when I change from radians back in degrees, I can use the same formula. I just change this guy moves over here. and my x moves over here. Okay? But let's graph sine. Okay? I want to graph sine. So the exploratory challenge. We're going to consider the function f of x equals sine of x, where x is measured in radians. Okay? So now, I want to, and I'm going to draw this over here where the video can't see it. We're going to draw our unit circle. What is my radian measure right here? 0, right? Good. So 0 is my radian measure. What is my coordinates of my point right here? Good, Nick. Nick's on point. Yes, you do. Yes, you do. And this was part of your homework for today. How about this point right here? How many radians is that? How many degrees is this? 90. And how many radians did we just find 90 degrees to be equal to? Pi over 2. So this is pi over 2 radians. What's the coordinates of this point? 0, 1. What's the radian measure here? Think about this. This is pi over 2 radians, right? We're adding fractions, right? So this is a half pi. That's another way of saying pi over 2, right? If that's a half pi, that's a whole pi, right? This is pi radians. And what's this point's coordinates? -1, 0. Very good. This guy down here, I got pi over 2, 2 pi over 2, which simplifies to pi. How many pi over 2 here? 3 pi over 2. And what's the coordinates of the point down here? 0, -1. And then I complete the circle. I can go back to 0, or I could call this how many radians? 2 pi. Because a full circle is 2 pi, right? Notice that 0 radians and 2 pi radians have the same coordinate points, right? So now, which one of these, the x-coordinate or the y-coordinate, is my sine? Who remembers? 50, 50, 90. It's a 50-50 question. You got a 90% chance of getting it wrong, right? It's actually our y. It's going to be our y. Sine is my y. Okay? So, when now we're back to the table. I'm going to graph at 0 radians. I'm going to graph at pi over 2 radians. I'm going to graph at pi radians. I'm going to graph at 3 pi over 2 radians. I don't like making my fractions like that. I like making them like this, but I felt like I was running out of room there. And then 2 pi radians. I didn't need as much room. Oh, they want me to go out to 5 pi radians. Holy snap. They don't have enough room then, huh? Oh well. Let's do this. So, again, remember, my sine is my y-coordinate, right? So when my angle is 0 degree, or 0 radians, I almost did it. When my angle is 0 radians, what's my sine of my angle? 0, right? So, should we do this in red? My sine is 0. When my angle is pi over 2 radians, what's my sine? 1. When my angle is pi radians, what's my sine? 0. 3 pi over 2? Negative 1. Good. And 2 pi? 0. Can I say you guys are on point today? Y'all are on point today. Was it the fire drill?
Yeah.
The fire drill got us on point, right? So let's graph these points on the graph, shall we? Where's my first point going to be? How about at the origin? Is that a good place to put it? Okay. Now, where is pi over 2 on this graph? Where's this pi over 2 radians? So I don't have pi over 2 anywhere on here, do I? Do I make it up or do I?
It's half pi.
It's half pi. So what does that mean, Andrew? Like right here?
No, or in the middle.
Oh, in the middle. Okay. Got it. Like this?
Yeah.
Right here? Except my sine is 1, so I got to go up to 1. Okay? Where's my next point going to be? Let's say you, Tabitha. Pi and 0. Good. Pi and 0. And then at 3 pi over 2, I'm at negative 1. Right, Brandon? So I'm at, this is 0. This is pi over 2. This is 2 pi over 2, which simplifies to pi. This is 3 pi over 2 and negative 1 right there. And then at 2 pi, I go back to 0, right?
Yup.
Now, I'm going to put a gentle curve in to connect all these dots. Gentle curve. Ah. No. Gotta do that again. Oh, snap. Okay. What do you think happens after 2 pi? It's going to do the same thing again, right, Nick? So, at pi over 2, well, 2 pi plus pi over 2, it's going to be at 1 again. At 3 pi, it's going to be at 0. Pi over 2 after that, it's going to be negative 1. And then at 4 pi, it's going to be at 0. Bottom right when you're done, Kaylee. Thank you. And then I just repeat the gentle curve. What do you think happens after that? Wash, rinse, and repeat. It's just like washing our hair, right? So pi over 2 after 4 pi, it's back up to 1. And it goes down to 0. Gentle curve, up and down. Now, what about over here? What do you think it's doing over here, Stephen?
It's going up.
Does it go, so is it bouncing off here and going up again? No. It looks like it's going up from 0, right? So going the other way, it should be going down, right? Back there, right? Huh. And there we got sine of x. Except now x is in, say the word again, radians. But that was weak. Let's say what was our x in? Radians. Oh, that was much better. Much better. All right, we're going to turn to Exploratory Challenge 2. That is like 4 pages in. I think so, something like that, right there. Yeah, Exploratory Challenge 2. This is going to be cosine. So, it's going to shift. It's going to shift a little bit. So now, Now we're going to do cosine. And we're going to do the same values of x that we did for sine. So what were those values? They were multiples of pi over 2, right? So our first one was 0. Our second one was pi over 2. And then it was pi. And then it was 3 pi over 2. And then it was 2 pi. And do I need to do anything after 2 pi? Why not? Go ahead, Jeff. Come on, you got this, man.
Like, yeah.
It repeats, right? It does the same thing it did here. Just does it again. Wash, rinse, repeat, right. All right, so now let's look. Remember, in the unit circle, what coordinate gives me my cosine?
The 1 further.
The 1.
1, 0, -1, 0.
So is it my x or my y? It's my x, right? Sine was my y. Cosine's my x. Okay? So when my angle is 0, my cosine is 1. Let's do that in red. When my angle is pi over 2 radians, I'm at a cosine of 0. My x-coordinate is 0. When I'm at pi radians, there you go. We're getting the hang of this. 3 pi over 2, 0, and 2 pi. Back at 1 again, right? Excuse me. So now, last one, I started at the origin. This one I started at the origin, right?
No.
Couldn't catch you guys. Must be the bifocals. All right. So, did you just go there? It was like a slow-pitch softball, man.
Yeah.
All right. So where's my first point go then? If it doesn't go at the origin, where does it go? It goes at 0, not 1, 0, 0, 1, right there. And then at pi over 2, that's when cosine's at 0, right? Right here. And then at pi, where am I at? At pi radians, what's my cosine at? -1. At 3 pi over 2, I'm back at 0. And at 2 pi, I'm at +1. And now I do a gentle curve here, and I do... Oh, that was much better than my sine. Now, do I need to do it again? Do I need to table some more numbers, or can I just repeat the process? Repeat the process. Here's what I like doing. Notice that here, what's the distance between this peak and that peak? 2 pi, right? The distance on the x-axis is 2 pi. So if I go over 2 pi from here to 4 pi, where's my cosine going to be at? 1 again, right? And if I go 2 pi from this point, where's my cosine going to be at? 0, right? 2 pi from that is right here. And 2 pi from this point, and 2 pi from this point. See how I did that? And so, I got another gentle curve. And then, bam, and bam. So are we? Yeah. Yeah. And then here, what happens over here? Goes down, right? And there ain't no place to go but down. So 0, -1, whack. Okay? So we graphed cosine. What are the differences that we see between sine and cosine? Look to the page on the front. Let me ask you this. Here's your homework. Here's your homework, and we're going to make this due on Thursday. Turn to, where is it?
The problem set.
Is it on the problem set?
Or do you want to go back to one?
No, I don't want to.
Exploratory challenge 3.
Yeah, is there an
Bottom of the page, whatever.
is it at the bottom of that same page? That's not there. It's not there. It's not there. There it is. All right, go to Exploratory Challenge 3. Your job is to graph both sine and cosine on the same graph. So those of you like Tabitha who likes different colored pencils, you'll love this activity. Yeah, because you get to do two graphs from the same graph. You always have colors. Really? What happened? Oh, well, we're putting the home back at homework then, aren't we? Yeah. So, this is your assignment. Do, what's today? So do Thursday. Do Thursday.